We now work through an exam-style question involving the binomial theorem. We're asked to find the value of the constant term in the expansion of the product of x to the power of 4 and the binomial x plus 2 over x squared raised to the power of 5. Now, before solving this problem, let me just quickly point out that when we say constant term, this means the term without an x. And perhaps one of the best ways of finding the term without an x is to look for the x to the power of 0 term. And the reason for this is because x to the power of 0 equals to 1. Alright, that being said, let's see how to solve this problem. Now, to take care of this question, what I would recommend is to start by completely ignoring this x to the power of 4. In other words, I would start simply by focusing on this x plus 2 over x squared raised to the power of 5. Now, we know from the binomial theorem that x plus 2 over x squared raised to the power of 5 is equal to the sum from r equals to 0 up to 5 of the binomial coefficient 5r times x to the power of 5 minus r times, in parentheses, 2 over x squared raised to the power of r. Now, if you've watched any of my previous tutorials, you already know that I like to spend a minute or two to focus on this term that I'm underlining in green that I call the general term of the expansion, this t of r. So if I just copy that here, that's t of r equals to the binomial coefficient 5r times x to the power of 5 minus r times, in parentheses, 2 over x squared raised to the power of r. Now, to simplify this, the first thing I'm going to do is distribute this power of r inside these parentheses. And remember, when we have a fraction like this one raised to some power, the power distributes onto both the numerator as well as the denominator. So this equals to the binomial coefficient 5r times x to the power of 5 minus r times 2 raised to the power of r over x to the power of 2 raised to the power of r, which is x to the power of 2r. The next thing I like to do is to get rid of any x's that we have on the denominator. Here we can see that we have x to the power of 2r on the denominator, and so to get rid of it, I use the fact that I can rewrite this expression as 2 to the power of r times x to the power of negative 2r. Keeping that in mind, our general term can therefore be written as the binomial coefficient 5r times x to the power of 5 minus r times 2 raised to the power of r times x to the power of negative 2r. Finally, when we multiply these two powers of x together, we add this 5 minus r and this negative 2r. And in doing so, we can therefore state that t of r is equal to the binomial coefficient 5r times 2 raised to the power of r times x to the power of 5 minus 3r. And this 5 minus 3r is 5 minus r plus negative 2r. And so this is the general term of the expansion x plus 2 over x squared raised to the power of 5. And in fact, I'll go ahead and box that initial result. Now, going back to the original problem, remember we're multiplying this by x to the power of 4. So any term in the expansion will be the product of x to the power of 4 and our general term that we have here. In other words, the general term of the product of x to the power of 4 and x plus 2 over x squared raised to the power of 5 will be x to the power of 4 times t of r. And that's equal to the binomial coefficient 5r times 2 to the power of r times x to the power of 5 minus 3r times x to the power of 4. And now, to multiply these two powers of x together, we add the powers to which they are raised, which leads us to x to the power of 4 times t of r equals to the binomial coefficient 5r times 2 raised to the power of r times x to the power of 9 minus 3r. And that's the general term of the product of x to the power of 4 and x plus 2 over x squared raised to the power of 5. Alright, now that that's done, we need to find the constant term. Now remember, the constant term corresponds to the term without an x. And the only way for this power of x to disappear from any one term is if we're dealing with the x to the power of 0 term. In other words, when we're asked to find the constant term, what we're really being asked for is to find the x to the power of 0 term. Now, looking at the power of x that we have inside the general term here, we can state that we'll be dealing with the constant term when x to the power of 9 minus 3r equals to x to the power of 0. And now both sides of this equation are written as powers of the same base. In other words, both sides of this equation are powers of x, so we can get rid of the x's altogether. And that leads us to the equation for r. 9 minus 3r equals to 0. Now solving this quickly leads to 3r equals to 9, in other words, r equals to 3. And I'll just box that value. There we go. Now what this r equals to 3 is telling us is if we replace every single r that we see inside the expression we have boxed in yellow here by 3, then we'll obtain the x to the power of 0 term. In other words, we'll obtain the constant term. So let's go ahead and replace every r that we see by 3. And I'll just do that in the right-hand corner here. There we go. So replacing r by 3, we have the binomial coefficient 5, 3, times 2 raised to the power of 3, times x raised to the power of 9 minus 3 times 3. That's equal to the binomial coefficient 5, 3, times 2 to the power of 3, which is 8, times x to the power of 9 minus 3 times 3, so that's 9 minus 9, which is 0, as we expected. Now, by all means check with the binomial coefficient formula, but the binomial coefficient 5, 3 is equal to 10, and as we said previously, x to the power of 0 is equal to 1. So the constant term is equal to 10 times 8 times 1, and that's equal to 80. And we're done. We've just found the constant term in the expansion of x to the power of 4 times the binomial x plus 2 over x squared raised to the power of 5. And there we have it. That's it for this tutorial.